It's called system function pre-upgrade. I can show the code maybe after this presentation. So welcome back, everyone. Welcome for this quick presentation on unlocking the power of other blockchains. So we are going to talk about how to connect the IC network with other blockchains, mainly with Bitcoin today, because this presentation that you will see focuses on Bitcoin. You could generalize to other currencies. It would be, of course, more complications for something like Ethereum. You would have to think about a few more generalization, but you could apply these principles that I'm going to talk about for any currency, more or less. So a problem that has been like a huge problem that has been um, preventing adoption of cryptocurrency is the problem of fragmentation between ecosystems. For example, in our scenario, we have, let's say, Tom here, and Tom has a Bitcoin, as you can see here. He has some Bitcoin, and he wants to use it for applications like Ethereum, Uniswap, or Curve Finance. But those applications, they are deployed as smart contract on Ethereum. So Curve contract here, Uniswap contract here. And so this is the Ethereum world. And the Bitcoin that you see here, it exists only in the Bitcoin world, but in the Ethereum world, it doesn't have any existence, any real existence. So the problem is, how do we make it possible for Tom to be able to use his Bitcoin on the Ethereum network and to be able to use his money on the, sorry, I clicked, on the Ethereum chain? The solution has been to create a bridge. So as you can see here, we have this on the left Ethereum part, and on the right, we have the Bitcoin part. And this is a bridge. So it looks like a bridge. What is a bridge? A bridge is going to be able to control a wallet here, where Tom will be able to send his Bitcoin, and is also controlling a contract on the Ethereum side. So anytime there is a Bitcoin sent, there is going to be a Bitcoin copy on the Ethereum network. And so similarly, if we destroy, I'm sorry, I think it's automatic, the animation, then it's just cutting the slides. I'm going to go with I'm going to go with another presentation which don't have the animation. Sorry for that. Okay, we are safe now. We don't have the animation. So every time you send a Bitcoin here, then you're going to be able to emit a wrap Bitcoin. So wrap Bitcoin is the most common type of wrap asset that we know of. But the problem of this approach is the bridge here. How do we know it's trustworthy? How do we know it doesn't create more than it should? Or how do we know that it doesn't take control over our wallets? This has been a problem. The solution right now is that essentially the bridge is managed by multiple companies. So all of them have a vested interest in not hacking the bridge. For example, companies that have interest in having the wrap Bitcoin existing on Ethereum. So for example, companies that would leverage like Curve or Uniswap, or companies that are providing services in the crypto market in general. And there are multiple of them with as much independence as possible between the companies. And so they have to, essentially, this is a multi-sig wallet, and this is also a multi-sig contract. So there is a level of security that is considered high enough. For some bridges, we haven't seen hacks, but for many, many bridges, we've seen thousands of hacks, and people have lost their funds and stuck on a chain, not being able to go back. So this is a problem that on the IC, we also have some security assumptions. But again, just like we talk with the HTTP outcodes, we have a native approach of doing things. So it's not a new provider. We are not adding a layer on top of the main protocol. We are actually backing the Bitcoin integration into the protocol, which means that canisters can receive, hold, and send Bitcoins, and not raw Bitcoin, but real Bitcoin. So you can think of a canister as a wallet that it has an address on the Bitcoin network, and it's able to sign transactions. If you think about it, it's even better than a wallet. It's some people say it's a smart wallet because it can perform computation, it can perform automatic actions, it can be triggered upon events. You can customize the wallets for each user. So it's a very, very smart wallet which you can build on top of a canister. So how does this magic integration work? Well, on a high level, it works the following way. The Bitcoin, so the ICP nodes that you see here are connected with some Bitcoin nodes. So essentially, the networks are interconnected. You can think of it as like real connections between the nodes, like they are communicating with each other. And so every time the Bitcoin blockchain has an improvement, like there is a new transaction, there is a new block, new TXOs, the nodes on ICP are aware of that. And essentially, they create a copy of the Bitcoin blockchain. They remove some parts that are unnecessary for what we want to do. But essentially, there is a copy in a canister that is called the Bitcoin canister, which tracks all the ATXOs, the balances. And as a user, you are able to use this Bitcoin canister through intercanister call to submit requests. So you go through the management canister as we've seen yesterday. But essentially, in one line, you are able to get the balance of a Bitcoin address. You are able to send transactions. You are able to sign transactions. And then, of course, it works in one way. So the ICP network is always synchronized with the Bitcoin blockchain, but it also works in the other way. When you want to emit a transaction, you need to broadcast this transaction to the Bitcoin network. And so ICP nodes are able to broadcast the transaction to as many nodes in the Bitcoin network as possible. And then once the transaction is signed and emitted, then it's just something that happens on the Bitcoin network. It does not depend on ICP anymore. So, oops. The connection between the two networks is pretty simple. Now, the question is, how do we actually sign? Because if you think about it, you need a key, like a private key, and this private key needs to be somewhere. So if it's stored in a canister, where is exactly the key store? Is it stored in one node? Is it stored in multiple nodes? And if it's stored in multiple nodes or one node, can't we just hack the key? Like, can't we just take the funds and get the key? So yeah, the whole protocol lies on the fact that this key, which you can use in your canister as a developer, you can access and sign transactions. So you have a private key somewhere, can never be accessed by any human or any machine. Why? It's called threshold ECDSA. So ECDSA is this cryptographic protocol that is used in Bitcoin, one of them. So you have a set of algorithms that work together. You have the algorithm to generate a pair of keys, and then you have the algorithm to create a signature using the private key, and the algorithm to verify the signature using the public key. So that's the basis of everything. You can send a message with the sign a message with the private key, and anyone is able to verify that with the public key and know that this message was indeed signed by you. Threshold ECDSA is exactly the same types of algorithm. The only difference is that there is not one private key, but there are multiple shares that are shuffled around all the nodes in the subnet. So the private key is never constructed. It's important to understand that the private key never lies in one place at any moment in time. Like the algorithm that create a signature do it by aggregating the shares. Like everyone is going to create mini signature and aggregate those signatures. And at the end, assuming you have enough nodes that collaborate, you are able to create a signature. And now this signature and this consensus threshold t-ECDSA has exactly the same guarantees than the ICP consensus itself. So it's again part of the ICP consensus, the same guarantees, 2/3 of the nodes. And essentially, that's how it works under the hood. So the security depends on the number of nodes within a subnet, if you've been following, but it also depends on how secure those nodes are. And there is one little detail compared to a multisig. So usually people say it's a multisig. It's actually quite close to the truth. But the difference with a multisig is that the the shares can be different. Like for example, if a node leave and we have a new node that joined the subnet, the keys will be shuffled around and the shares will be reconstructed without having any impact on the final key. So you can have many different like repartition. You can like this can become the yellow can become the blue and it can be shuffled. And it can be modified, but the final public key never change. Otherwise, that would be complex for us developer. Like it would mean that if you deploy a canister, you would have a address that can change on the Bitcoin network. So it would be kind of problematic. Fortunately, it's not the case. So now we have all the blocks, and this just sum up everything that I've talked about. You have the ICP nodes, the Bitcoin nodes. Each ICP node is connected with 5 Bitcoin nodes. And on the other side, they broadcast transaction. So your canister is able to, through intercanister call, to check balances, create transaction, request a signature, and broadcast transaction. You lost me? Is there was there a problem with the stream? Ah, okay, yeah, I can see the. Hello, can anyone hear me? Yeah, okay, so I'm back. Sorry, I had an issue with the network. Yeah, so that's about it for the integration of the two networks. Now, if you look into the dashboard, so if we take a look at the ICP dashboard, how to get rich. If I knew that, uh, so there is a Bitcoin tab here, which will gives you information about the, like how the two networks are connected. So for example, you can see that this Bitcoin canister has 82 gigabytes of state. So this is the canister that I was talking about that is synchronizing the two networks. You can see what is the current Bitcoin height, block height that is synced. So this should be fairly close to the actual latest block on the Bitcoin blockchain. And we can see the number of tracked UTXOs. Now, if you take a look at this tab, you will also see this chain key Bitcoin. So what is chain key Bitcoin? What is chain key Bitcoin? So this is what is chain key Bitcoin. It's a Bitcoin on steroid. Essentially, why would we need that? So first question, why would we need that? If we think about it, the whole point of the Bitcoin integration is to be able to natively use the Bitcoin network and to not have those wrap assets, just as I was showing in the first slide, those wrap contracts, which can be problematic. The idea was to move away from that. So why are we adding a new kind of wrap asset? The problem is that even if you can use the Bitcoin network and you can still do it, like it's possible, you can build applications, you can use Bitcoin as a currency, you will never be able to move away from Bitcoin limitations because in the end, the transaction is always settled on the Bitcoin blockchain. So it has to go through the Bitcoin consensus and you have to pay Bitcoin fees and you have to wait the time that Bitcoin needs to settle. So usually it could be like 10 minutes or 30 minutes on the bad days. And so you can never move from this experience. If you are like a big DeFi exchange and you do maybe transaction once every 2 weeks, like a big transaction, it's not too much of a problem. But if you are working on like a game and you want, micro payments, you want to be able to pay really cheap and really fast little services, then it starts to become complex to use Bitcoin. That's why Chunky Bitcoin has been created. It's a native wrap Bitcoin on the internet computer. It's backed one-to-one by real Bitcoins, which I will explain in the next slide. And the good thing is that because we are using JC, we have the update calls like delay, and so you can make a transaction in 2 to 3 seconds. So 2 to 3 seconds finality, which is like 100 times probably better than the normal Bitcoin. And also, since we are on the IC network, you can easily plug in with any dApp. So if you ever want to build an application, like a decentralized application, and you want to integrate with Chainkey Bitcoin to have like a payment system, you can do that very, very easily, like in a few lines. There is the ICRC1 standard, which I already mentioned this week, and it's really easy to plug in with this token. Now, how does it work? It works with canister. So the good thing is that on the contrary to bridges, like traditional bridges, you don't need any third parties. So you don't put your trust into the hands of a few companies, but you do put your trust into the ICP protocol, and especially you put your trust into canisters. So there is one minter canister, one ledger canister. The ledger canister is the one that followed the ICRC1 standard, and it contains the Chunky Bitcoin transactions, balances, transfer method, and so on. The ledger can only be like the mint function and the burn function of the ledger can only be used by the minter canister. So the minter canister is a canister that has only one function. This function is to receive real Bitcoin, to store those real Bitcoin. So there is a wallet on the Bitcoin network that we don't see here, but essentially it's controlled by this canister. And when you send real Bitcoin, the minter will verify that you have sent them. And after a few moments, once the transaction is confirmed, the minter will send a request to the ledger to mint some token and give you some chain key Bitcoin. So you're always going to receive the same amount corresponding to whatever Bitcoin you have sent. And on the other side, if you burn some chain key Bitcoin, you will receive back some of your Bitcoin or all of your Bitcoin if you burn everything. And then, so this is like the kind of bridge part here. And then all the rest that happens on the IC side. For example, if I'm OpenChat has a feature where you can actually send Genki Bitcoin. So I can show you that. For example, I could send from here, I think. You can send ICP, but you can also send Genki Bitcoin. And so I could send to any user. Like the only problem is that it's really small, like decimals, because it's in Bitcoin. So I don't know how much is that. But yeah, all of this that happening on the IC. So it could be OpenChat, it could be any game, any application, social network, just needs to communicate with the ledger, and it's just one intercanister call and it's done. And in a few seconds, you can validate the transaction. So the use cases that we have, that's only getting started because, so I think now we have way more integration, but of course, Socialify. So Socialify is just a fancy word to say that you have more like financial features and use cases in social applications. So like OpenChat, I do use it quite a few times, like when I'm with friends and you just need to pay something quickly. It's probably one of the easiest way to send money to someone. You just send a transaction, takes 2 or 3 seconds. Crowdfunding. So there are a few crowdfunding, especially Funded is a crowdfunding platform on the IC that accepts payment in Genki Bitcoin. On-chain decentralized exchange. So with the Bitcoin integration, you are able to essentially have a decentralized exchange that works for many, many chains, like any chain. So you are able to, for example, contrary to Uniswap, which I've talked about, you can do swap on the Ethereum world. You cannot do like you cannot swap Bitcoin for Ethereum or Bitcoin for ICP directly. On a decentralized exchange, on the IC, we could imagine something really like completely multi-chain with the Bitcoin integration, and you could be able to trade anything for anything. So that would be the perfect world. I know some teams working on that. We are still in the early days, I believe, but yeah, Genki Bitcoin, of course. Bionic, which is an ordinal marketplace. So ordinals are NFTs on the Bitcoin ecosystem. And I'm not super familiar with ordinals, but I know that many people are interested in them, mainly because they believe that Bitcoin is the best database in the world, like the most decentralized. So they believe that having an NFT stored on the Bitcoin network is more valuable than any other network because it has more chance of like surviving long enough, which actually makes sense if you think about it. So there is an ordinal marketplace on the IC, which uses Genki Bitcoin and Bitcoin, and non-custodial lending protocol. So most people that hold Bitcoin, they don't do anything with it. They essentially just store it in a wallet and just wait for like the next 10 or 20 years if they believe in it. Non-custodial lending protocol would essentially make it possible for people that own Bitcoin to lend their Bitcoin to people that would need to borrow money. But the problem with that is that historically, Bitcoiners have been very reluctant to that because they don't want to put their Bitcoin into a lending company or protocol because they would take ownership of their Bitcoin and just the risk of it. So essentially on the IC, you could build a non-custodial. So there is absolutely no one that owns your Bitcoin. But it's still like something that we have to educate people on. I guess it's also something. So Finterest is one project that is working on that. If you think about it, there is still a security risk because you still rely on canisters. So it's better than what's out there, but it's not 100% secure. So I guess it depends on how much risk averse you are. But this is an interesting use case. Now, let's go to the example side. So if we go, and actually I have the repository ready. How do we actually work with all of this? So there are two things that I want to show you. There is the basic Bitcoin example. We can take a look at it. And there was the and the threshold t-ECDSA example. Okay, so let's start with the first one. So if you are interested, I can show you the link to this repository. Essentially, this is a simple Bitcoin application that is able to send and receive Bitcoin on the IC. So you are a canister that basically acts like a little wallet. The problem is that we would need to use the Bitcoin testnet because, of course, I don't want to pay for the real Bitcoin, or I don't want to lose them. So that would be like some problem there. So we need to use the Bitcoin testnet, but you will be able to receive and send Bitcoin. So if you want to take a look at it, that's what it would look like. Now we can take a look at the code. Uh, it's if you're not familiar with Bitcoin, it might be a little bit like overwhelming. So what I'm going to do is no, that's not what I want to do. Sorry. Yeah, actually, I wanted to show you. I wanted to show you this example, but I'm not sure if it's gonna work locally. That might be like a little issue with my ID because is this going to work locally? Let's see. I don't really want to deploy on the IC because it's gonna cost me quite a few cycles. Oh yeah, one interesting thing is it's the first time we've seen that argument. So we can actually provide arguments when we deploy a canister. Here, it's specified here. So this actor is defined as a class, which essentially means that whenever we are deploying this canister, it's gonna spam like an instance of it. And so when you have defined your actor as a class, you can give it arguments. And here, for example, the argument, we only have one, but you could have multiple, is just the network type. So if we look at types, it's going to be the testnet or the mainnet. Yeah, mainnet, testnet, reg test. So it's here. But every time you deploy a canister, you could be able to have arguments. And then when you want to deploy from the FX, you can use the argument flag and specify your arguments in the candid format. Be careful, it's candid format. And yeah, you can essentially provide arguments. Okay, so I seem to have some issue here. File. There is a missing piece here. Oh, okay, yes. I think I got it. Okay, so yeah, we need to import quite a few external modules to work with. So this is like crypto libraries, which I'm not going to look into because it's not something that I'm confident, like it's not something I've been working on. But essentially, those are like crypto libraries to be able to work with the threshold t-ECDSA API. So all of what we're doing today is quite low level. It's okay if we don't understand everything. Just need to see the big picture. Now, if I deploy, I should be able to, yeah, it should work. Uh, Looks like there is an issue with the argument. So let's take a look at the types. Oh yeah, it's test. It should be like this. So there is an issue. There is a Yeah, there is a typo here. It should be testnet with a minus, not a capital letter. Okay, finally, looks like we are done. It's deployed. So let's take a look at our Bitcoin wallet, what it looks like. We are able to get the balance of an address. We are able to get the current fees on the testnet. So yeah, okay. It doesn't work with the problem is my canister is deployed on the local network and I'm trying to call outside of it. Can I? Okay. I guess I don't really have a choice here. So so if we want to have a chance of of seeing something, we need to deploy on the IC. Ah, I made a mistake. Sorry. Let's pray. It should be good now. Okay, now let's take a look at this address. This is our canister that is deployed on the IC. Now I should be able to use this to get the fee. So I'm calling the Bitcoin testnet here. But the Bitcoin testnet is like a real network that is exactly like the Bitcoin, the real Bitcoin. So you can see it takes some time. So not sure exactly how I should use this, but I guess it's the fee. So we are calling this method get current returns the 100 fee percentile measured in millisatoshi. Percentiles are computed from the last 10,000 transactions. Okay. So we could send from an address if we have like the Bitcoin that we own in this wallet. I guess currently we don't own any Bitcoin because we don't have any address. So what we need to do is to get the address of this Bitcoin wallet. To do that, we need to call this method. This method is going to generate an address for us. So it's going to create a pair of keys. And so it takes some time. It's calling the management canister. And then we have this address. And this address is an address that we own. So this canister owns this address on the Bitcoin testnet. I'm not 100% familiar with the Bitcoin testnet. So the server wallet is temporarily so there should be some testnet faucet that we can use. Okay, faucet is overloaded. Uh, it seems that it's super slow. I don't know if we are going to be able to receive Bitcoin. Let me see how they. So yeah, we have done step 2, which is to generate an address and then receive Bitcoin. Okay, that's not great. I don't know if someone knows a Bitcoin faucet that we could use, but what I wanted to show you is that we could receive some Bitcoin to our canister and then we would be able to send it to another address or back to the faucet. Unfortunately, I'm stuck at the faucet side and it's not something related to the IC, but something I was scared of, which is that Bitcoin faucet are usually hard to get into. I mean, I think this one would work, but this one is really slow. It takes like a few hours to answer, so let's see. No, I know it's not gonna be a good idea to use this one. And this one seems to be full. Okay, well, let's leave it there. So assuming we received some token, would have been able to use this, get our balance, and see some number appearing here. It's gonna be 0. And yeah, that's one example. Of course, we could do more things after that, but that's what I wanted to show you. Now, the second example was this one. So let's close. The second example was a threshold ECDSA example. So this one, and where is the, it's here. So it's a canister that leverages the threshold ECDSA API. And the threshold ECDSA API is the API that is in the management canister that we've already seen. So you are able to sign or create keys. And this can be used not only for Bitcoin, but for many, many purposes. For example, this one is an oracle. So yesterday we've talked about oracles, we've talked about Orally network. And essentially they are able to create ECDSA signatures on any message. And then this can be broadcasted and verified by any entity outside of the IC. Yeah. So how do you create a signature? Again, we simply use the management canister ECDSA public key and sign with ECDSA. So each canister is going to have access to a specific public key, and each canister is going to be able to sign this with the corresponding private key. And here you have the public key and you have the sign method, and that's about it. So a use case for that would be being able to send transactions on Ethereum, for example. Like this is a good example. You would be able from a canister to send transactions and sign those transactions. And so it would be the first time it would be the first time in my knowledge that we can create transaction and broadcast those transaction on Ethereum in a decentralized manner, and also something that you can fully automate. Like you could create like so canisters are able to create automations, like they can run actions, perform actions every 10 minutes, every 25 minutes. So that would make for a really good decentralized bot, for example. Yes, okay, this one I was looking for. It's an example that also is quite interesting. This one is probably simpler than the one that we've seen, because we've seen ECDSA and Bitcoin integration, which is like low-level topic. This one is more high-level. It's a simple example where essentially you have a sale application where user can pay using chain key Bitcoin. So we can try that because I think there is an example deployed on the IC. Ah, we are not able to generate the QR code. Well, this is my address. Uh, I'm going to try something. So this is my Motoko store, and I'm going to see. Ah, no, it's not gonna work because, wait. So this is a principal, it's not an account. So I'm not sure how they, like, seems that it's a little bit. Okay, it's working with principal. I wanted to do a test from OpenChat to this application to see if I could move my chain key Bitcoin around, but I'm not gonna try here because I have a feeling that it could cause some issues because this application is using principal, OpenChat is using account for sending and receiving. Um, the account is derived from the principal. Like this is not something that we've seen, but on the IC you have your principal, which represents your identity, but then you can have multiple accounts. Essentially, you have a main sub account, and then you have two to the power of 32 sub accounts, which you can essentially use. This is meant for you to have like multiple wallets within the same application. You can have like a main wallet or a saving wallet, something like this. So yeah. And and that's about it. That's all I have to say about integrating with other chains, threshold t-ECDSA. Is there any question in the chat? If not, then I'll leave it here. I'm a bit disappointed by this example. I thought it was gonna work out of the box. Might need to leave a review or a pull request here. Thanks everyone for following. Next session, yeah, the final project next session in 1 hour and 10 minutes. We will talk about the final project together. So I see you there, okay? Good afternoon and see you.